It's always good to see how people are using LLMs for innovative purposes. In this video, I'm going to show you this new tool called as llama-zip. Llama-zip is a command line utility for lossless text compression and decompression. It functions by leveraging a user-provided large language model as the probabilistic model for an arithmetic coder. This allows this utility llama-zip to achieve high compression ratios for structured or natural language text, as fewer bits are needed to encode tokens that the LLM predicts with high confidence. So primarily you have your own zip tool powered by AI for free on your local system by using this llama-zip utility. By employing a sliding context window, llama-zip is not limited by the LLM's maximum context length. So you can use as bigger a file as you like. It can also handle arbitrarily long input text, whether you just put it within your console or you put it in a file. The main limitation of llama-zip is the speed of compression and decompression, which is limited by LLM's inference speed and of course your GPU size. But you can even use it on CPU by using a lesser quantized version. So in this video, we are going to install it on our Google Colab free version, as you can see here, and then we will see how it works. You can use the same commands on any Linux instance or in the terminal in the Windows or in the Mac OS. So let's get started. And of course, I will drop the link to this GitHub repo in video's description. So if you want, you can also try it out. So let me first install some of the stuff, which includes llama-zip on this Google Colab, and before that let's change the runtime to GPU because we will also be using a quantized version of Llama 3. So let's first install. So in this one, all I'm doing, I'm just marking it as a markdown. You can remove it if you like, and you see that I'm simply git cloning llama-zip and then downloading this meta llama 3 8 billion Q8 from Hugging Face. So let's run it. It is going to first git clone the repo, then it is going into that repo, and then it is downloading that Hugging Face model, and then we will go into it. The speed looks really good of Google Colab. I'm quite impressed. Let's wait for it. It'll take too long. And installation is almost done. Model is downloaded. Let's wait for it. And also at the backend, it uses llama CPP, which is a Python wrapper on this C++ library for LLM inference, which makes it easier to do your inference on CPU or even commodity GPU. Almost there. And all the installation is done. It took around 5 minutes, so be patient with it. And then this is all there is to it for installation. And in order to run it, all you need to do is to just use this as an interactive mode. So here what we are doing it, we are calling that llama-zip utility. We are calling the model which we have downloaded, and then -i shows in the interactive mode. Let's check it out in the interactive mode first. It is loading the model. Let's wait for it. And that loading means that it is loading onto the GPU. Or you can run it in the batch mode like this. For example, I'm just giving it a text like, hello, this is Fahad. And then with the llama-zip, I'm calling the model and then calling the text. Let's wait for it. It is compressing, as you can see. And it just depends on the number of tokens. So there you go. So this is your compressed form, and you can decompress it quite easily. So something like that. Let me quickly run it. And then I'm just going to put this here. And for the tokens, I'm actually going to put this in the tokens. I'm just going to say that tokens is equal to this. I'm not sure if I need to put double quotes, but let's check it out. Let's wait for it. Should be fun to see what it says. Hello, this is... There you go, see. So not only you can do the text one, but you can also compress the whole files. And now let me show you how to compress a file. Just click on this folder icon and then go into the llama-zip directory or wherever you want to put your new file. I already have created this my test.txt. If you want to create your own or upload your own, feel free to do it. For uploading, just click on this icon, or if you want to just create a file here, click just in front of that directory on these three dots and click new file, and then it will appear on the right hand side just like this. I'm clicking on this file, double click, and it is going to open the file here, and you see this is the file where I have put in simply hello, this is Fahad and it is cold and sunny in Sydney today. So I'm just going to close this file, and I'm also going to close this tab. Let's see how can we use this llama-zip to compress a file. So all I'm doing, instead of giving tokens or text, I am just redirecting this output to this command. So let's do it. So llama-zip is loading this model meta llama 38 billion, and you see it is compressing it. Let's wait for it to finish, shouldn't take too long. It also shows the ETA, that is correct. And there you go. So this is what we have in terms of compression, and similarly you can simply decompress it. Let me show you the decompression. So you see, for the compression we use dash C switch. For decompression we use, yes, you guessed it right, dash D. So let's put this text here, the tokens, and then let's run the llama-zip to see what it decompresses into. And of course you can even redirect that output of that decompression to another file, and then that's it. Now you can also specify the window overlap with the dash W1, and you see that, by the way, it has decompressed it pretty nicely. So I was saying that there is also dash W switch which you can use to overlap between the end of previous context window and when it starts new. The default is 0%, which means that the context window is cleared entirely when it is filled. Higher values can improve compression ratio but will slow down the compression and decompression. So I would say that stick with the default, don't even change it. But yes, if you're a huge text, and maybe use dash W1. You can also use, there's another switch called as GPU layer, which you can find on their GitHub repo. I'll actually quickly show you. There you go. So this is what I was talking about, dash W, and then this is the N GPU layers. If you want to offload it into GPU, simply use this one. So if you set it to -1, it is going to offload everything to GPU. So that is where that is. Also, it has shown some of the compression level for some of the Calgary dataset files, which is quite interesting if you're interested to read. But all in all, Alex Buzz has done a good job, I think. Interesting tool. Really happy to see some new and novel usage of LLMs. I will drop the link to his GitHub repo in video's description. Let me know what you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.